This is a series question from the 2014 exam. So they gave us a Taylor function right here. We know it's centered at 1. They told us, and you can also see right here, it says x minus c. First thing they want you to do is find the radius of convergence. So if we're going to find the radius of convergence, we need to use the ratio test. But before doing that, you should actually know what the answer is. So we see there's no factorial, which means we know it's not an infinite radius of convergence or a zero radius of convergence. And if you look right here at this exponential piece, that will tell you what the radius of convergence is, so it's going to be 1/2. Well, let's go ahead and show it with the ratio test. So we take the limit as n goes to infinity, an plus 1 over an. I always write that because the first point is showing the ratio, and since I automatically flip this and multiply by the reciprocal, I write that just to ensure that I would get that point. I can't imagine they would really take off the point if you had already multiplied by the reciprocal, but it just was safer. So flipping this one over. So we go through and cancel whatever we can. The negative ones don't mean anything because it's inside absolute value. We have an extra x minus 1 on top. We have an extra 2 on top. And now we see that our degrees are equal, which means our limit is going to be the ratio of the leading coefficients. So that tells us, again, you want to get the x minus c by itself, so that's less than 1/2, and that is our radius of convergence. Part B says find the first 3 non-zero terms in the general term for f prime. So the first thing I'm going to need to do is write out the Taylor polynomial for f. So we start at n equals 1. If I plug in n equals 1, I'm going to get a positive 2 times x minus 1. If n is equal to 2, we're going to get a negative 2 squared over 2 x minus 1 squared. If n is equal to 3, we're now going to get a positive 2 cubed over 3 x minus 1 cubed. And it asks for first 3 non-zero terms, so I could stop right here. Now, it's always good to look and make sure that you have like consistencies or, things are following. So I have 2 squared, 2 cubed, first power, second power, third power, divided by 1, divided by 2, divided by 3, and I have an alternating. Not all Taylor polynomials will have a nice pattern like that, but a lot of them do, so use it for your advantage. Now they wanted us to take the derivative. So if this was f, so f prime is now going to be 2 minus 2 squared x minus 1 plus 2 cubed x minus 1 squared. And it keeps going on. Part C, the Taylor series for f prime about x equals 1 found in part B is a geometric series. Find the function f prime to which the series converges to and use this to find f. Well, they gave us a huge hint telling us that this was geometric. So f prime, we know our first term is 2. Our ratio, what we multiply the next term to get the next term, will be negative 2 x minus 1. Remember, the sum for a geometric series is a over 1 minus r. So this would be 2 over 1 plus 2 times x minus 1. They want me to integrate this, so I'm first going to simplify it. So when I integrate that, we're really going to do a u substitution. Our u is going to be 2x minus 1, so our du will be 2 dx. So out in front, we're going to end up with a 1/2. Then we're going to integrate 1 over u, du. The integral of 1 over u is the natural log Oh, there was a 2 up here, so this can go ahead and cancel that, so I don't have that 1/2 anymore. And integral of 1 over u is the natural log of u, which would be natural log of 2x minus 1. So this would be your function for f. And of course, when it's not a definite integral, so you have your plus c. Now remember, the c is going to be the first constant of it. So we know it was given us that f of 1 is equal to 0 somewhere. No, we know that, because if we plug in 1, we're going to get 0, so c is in fact 0. How was this one scored? Part A was worth 3 points. 1, did you set up the ratio? Find the limit, find the radius. B is worth 3 points. 2 for the first 2 non-zero terms and 1 for the general term, which I didn't even read that I needed the general term, so I would have missed that point. So the general term then would have been 2 to the n over n, x minus 1 to the n, and then when we take our derivative, we'd have 2 to the n, x minus 1 to the n minus 1. And then part C is worth 3 points. 1 for finding f prime, the sum of that. The second point from integrating, and the third point for finding c.